Yes, we are
And
seeing the
today,
screen.
thank you. Thank you for confirming. And I'm clear enough to listen to everyone. So today, myself, Akshay, so I'll be complete in charge of this particular workshop for all the technical deliveries. So today we would be focusing on civil annex. So yesterday we have done with the orientation program where we have actually seen what we would be doing with the total workshop. And for today, for those who are very new, what civil annex or Midas civil is. So we would be looking some of the aspects of what the new things that we have come up in civil annex with regard to the automation or the easiness of modeling. So I hope my screen is changing. The slides are changing. You're able to see the slides are changing. Can you confirm anyone?
Yes,
Yeah,
please.
perfect. So now introduction to Midas. So we are a civil engineering domain company with over 10,000 engineers, I can say till date. And, we have all over 120 distributions. And just for the inspiration, I would like to project these are the companies with whom we are already associated since decade. And majorly you can see the companies which have been listed from Nigeria itself also, like these are like government and private companies, which you can see. And also we have also create with some major applications, as you can see, which have been built earlier. So now the purpose is just for the inspiration part I wanted to project. And I would just give you a very brief overview what civil annex is and what we are going to do in this. So I'm not going to project lot of things which we have as complicated, advanced. Today, our agenda is very simple. Let's keep very simple things to learn at the very first part and then move towards what we say is the advanced capabilities. So as you see, the civil annex part which you have installed currently provides you with the user interface, the performance, and also the file format has been changed. And you can see there is a typical search window which have been integrated. So as you can see over here, this is the functionalities of Civil NX which have been incorporated in this new functions. So as you see, there is a user interface. So user interface has been completely changed. Who would be able to recognize where you have used civil before, but that is okay. So as you can see, there are a lot of changes which has been done in UI with regard to the command, and then with regard to the weaving of the any model, right? The functions have been changed. So the specific functions or the additional functions have been incorporated for easy purposes, right? So as you can see, the tree menu has been quite customized to check with all the functions that you would be having. So these are some of the changes which have been inbuilt. So you take any of the bridge to design. So yes, we have the typical solution for that. And also performing analysis. So it is something that you would be able to see the analysis at a very one go, which analysis is typically again, whether it is eigenvalue analysis or whether it is a static analysis. So these are different type of analysis that you can see. And also, like if you see what are all the modeling features, then what are all the wizard based features. So as you see in today's date, we have been dealing with lot of conventional bridge structures. As you see now, as what Midas has come up with the solutions or the wizard is something on the lines of automation, or we think is creating model in very easy steps. Okay. So how to do that? It is something that you have the integrated wizards, and also, and you can see that it has the bridge model wizard, then it has different kind of capabilities of performing the analysis, right? And further, you can see these are the some of the wizards which have been incorporated. So I'll explain. We are going to do a detailed demonstration steps when it comes to modeling. Okay, I hope everyone has come up with the installation. Those who have joined online. For those who are currently here, I will be able to resolve them in meantime. Okay, so let's start with how this typical function works. So basically, let's have the application and start learning how it is going to be useful. So because in presentation there are a lot of things to explain, but owing to the time constraints and the delay that we have for today, I'll just skip I'll just keep very short particular this agenda. All right. So when performing the design, so the design can be modeled in various steps. has come to Wizard. Then there is the typical grillage model, and there are some RSI model that we can do it, right? So these are the things which you can see as a check. And also, like as you could see, there are a lot of practicing engineers who have also joined, who have currently our licenses, which we would have a leverage as well to listen from their feedback or testimonial, to listen how they are being encouraged to use Midas before as well. All right. So these are some of the things, but I just want to give a very glimpse of what Midas can do in real-time analysis and the design functionalities. So again, I would not project this application as you can see onto the slide. There are just a lot of aspects of doing the analysis. There are like construction stage analysis, moving load analysis, and also like if you have to check for a given case, what could be the analysis maximum case that it would provide based upon the country code, then it can easily be determined. Again, there are aspects of moving load consideration the moving load simulations. So these are the things. Again, the construction stage analysis. Then there are the different ways that you can simulate the construction stages. So which requires the complex structural modeling, not the thing as involved. You can directly go in a very step manner. Please come in, sir. So here you can just take into characterization of different time dependent effect and also code based. So as we say today, we have done most of the things with respect to the code standardization. Again, there are construction stage analysis, and then there are other aspects to consider for moving load, then pushover analysis. So again, these are like part. Okay. Now coming to the main design functionalities, as you see, there are different design capabilities which are present. So the code-based design criteria are already there. So as you can see, Astro LR5D code can be designed. Then again, there are a lot of other things which have been there. Apart from that, what is different in civil analysis? What is, come up as a modification, or where Midas has modified, or what are all the things which have been equipped as a technology for today? I will also explain that part for today. As you can see, as Midas, it has been a very good integration with API. So what do you say API is application programming interface. So today we are not just with constraint to the numerical modeling just by creating a node or simply creating some sort of, typical just the model. However, today we are also confined, or we are just moved on to creating the numerical based modeling using various other languages. So it could be C++, C sharp, or whether it could be Python, and also different programming languages. So all the things comes up with the interface as the API integration, as open face interface. And also, as you see, there are the developments which have been done to optimize your Excel sheet. If you have to connect through the Excel sheet, so you will be able to do it. Again, as we say about Excel, how to connect earlier, we weren't able to connect your Excel with Midas Civil, right? So now with Civil NX, it will be enabled to connect your own user Excel sheet with Midas Civil NX. So that is the advantage that we have as Civil NX, where you will be simply able to connect to the Excel using the API plugin. Again, there are certain plugins which would be available for your own easy purposes. So to build an, the substructure is becoming easy, modeling the substructure or modeling the superstructure, or we have come up with the wizard for direct integration of how we will be doing the culvert right from analysis to the drawing. Okay. So we will be showcasing that as well. Oh, so that is something, the major development we have. So yes, so that is all about Civil Annex presentation. So we would be now moving towards the actual training part. We would be commencing the training now with the hands-on demonstration part. So I request everyone to open Civil Annex, Midas Civil Annex, so that we can start with the session for today. Okay. So let's move ahead. So one thing I would like to first explain is regarding the automation. As I say, automation is something that is more into how easily we can, get through the structural analysis and design. Okay, so it is to be noted that yeah, I hope you are able to see the video over here, right? You are able to see the video which I am playing.
Yes, we
Please
can.
confirm. Yeah. Okay. So as you see, I take the example of RC Convert. Let's see in a video what is the application of API plugins. When I say the Convert, as you see today, where we have come up, so there will be a dedicated separate tool which would be available in plugin for Convert design. So as you see, you just have to input what is the clear span, what is the clear height, right? So what would be the wall thickness? So automatically, sorry. So automatically the data would be updated into your drawing. So as you can see how we input the density, right, the subgrade modulus, the thickness. So this set of data would be beneficial to input just using the plugins. So now you can ask me, your question would be like how it is going to get benefit. I mean, what is the difference? So as you see over here, it is going to calculate direct moving load that you would be having based on the input. It will go on creating the model. So it is as that easy as that to directly connect with the wizard. So as you can see over here, okay. So as we see over here, it is directly creating the loads as well. So which we would be seeing for today. So here you can see that there is a density, then there are the aspects of which you have to change, whether you have to model a two cell or a three cell box convert. So based on that, you can modify the set of data. Okay. So maybe it would be like a set of application that you can use for the different projects you would be having. So maybe it is a kind of wizard which will automatically generate your model. Not just the model, it will also analyze, it will also design, and you can see over here it is going to provide you the design checks. Okay, the code based design checks would be done, and further you can also generate the drawings. Now earlier if you see, it was just limited to analysis and design, but now you can analyze as well, and even you can design the same along with the drawings. So as you see, it will automatically capture all the analysis images and also the design drawings. So as you can see, it is capturing the data actually when you have to submit. So for the purposes, if you have to submit to the client that these are the some analysis report, then you can simply use this plugin. You can just capture the plugin and it will automatically get it as a design report. So you can see, you can get in detail this particular report. Now engineer don't have to prepare the report by themselves. Okay, so they can automatically input the data, their user own data, and generate the design drawings. Okay, so this is customizable Excel report along with you would be getting all the details of the summary that you have. So maybe based on the different input of the load, let's say you have inputted any conditions, every other detail would be output into the Excel sheet. Okay. So you will be getting all the detail output using this particular API plugin. So even you can see onto the screen, even the drawings which are there, you would be able to get the drawings in a detailed manner. So even the analysis design output would be extracted into the Excel sheet just with the help of one click, right? So as you can see over here, how effective it is to generate it using the single wizard option. Thank you. Right? So this is comparatively easy to get all your condition and design checks using Civil NX, and that too using the API. So yes, even you can cross verify your own design data with the Excel sheet which it is going to generate. All right. So you can see it is a very detailed report which you can print or you can send it to the third party client that you are working with to showcase the result. So that is something, the entire report, software is going to give it to you. All right. So now let's go to the next step. Any questions so far? Please let me know.
Well,
Yes,
Yes, please go on.
yes, please. Can you slow down a bit and show us how you are,
Okay.
where you connected the APIs?
Okay, no problem.
Yes, please.
So
yes,
probably I should go back. Yes.
yes, that's exactly my question also.
Yes, so I'll
Mm.
just show it into this particular tab basically in Civil Annex. If you have Civil Annex, you can also able to access. Even you would be also able to check it from your side as well. So you can just go to plugins. So in plugins, you have the option to connect to the API. So I'll just showcase to you where this option would be.
Please, could you help to start from when you open
Yeah, okay, no problem.
the software? Yes, thanks.
Yeah, sure. You want me to play the video again?
Yes.
Okay, so here you can see, as I pause this, once you open the screen, you can see under the apps tab, there is a API settings. Okay, so again, I show in program. So everyone, I just pay attention how it is to be done. You can go to the apps. Once you open the program, click on file, click on new project. Okay, so click on file, click on new project. You can see this particular window would open up. This is a new project. Okay. Is everyone able to open? So now once you go to this app tab, then go to API settings. Then here, what has to be the very first step is to connect the API. This is the very first step that you have to do. So once you connect this, then further you would be able to see the plugins option and also the API settings. I mean, we can connect with different modules of languages or the Excel. Now, once you go to plugin, everyone, you can see onto that screen, there are different plugins which you will be able to see. Okay. So there is alignment in the marketplace. So this is a marketplace, but make sure that you are able to access the API first. How to do that? Go to API settings. Again, I'm explaining, no problem. I will go slow. Once you click on new project, go to apps, go to API settings, go to this connect option. So once you click on connect option, it will be getting connected. Okay. Then second is the plugin. So in plugin, you can see there are a lot of other plugins which are available. So the one which I have been explaining is with the Culvert. So you can just go to Culvert. You can type Culvert, RC Culvert. So here you can see this is the plugin. A plugin,
Uh,
what I mean that plugin is nothing but the wizard that we have. Okay. So you can find all the description that you would be having as a detailed modeling tool for this particular plugin. You can run this. You're able to access everyone.
Yes, we can.
Please, is it okay if you pause a bit and help and to allow us to repeat, let's say,
Yeah,
repeat
sure.
after you? Yes, because I'm at the place where you spoke about at the plugin where you do connect, and after that, I missed it because of your pace.
Okay, no problem. I'll go slow. No problem. So you can open the software. You can open the software, right? Go to API settings. Click on connect. Then you close this. After that, go to plugin option. Here you can type in a search tab under the marketplace Culvert option. Okay. So here you can type as culvert. Then you just click onto this and click on run. So once you click on run, you can see that your plugin would be able to use. Now, this plugin would be helpful in generating all the set of data. So everyone we would be now trying out with the plugin. So just see how it is going to be useful in generating the geometry or the detailed design and output report. Okay. So I'm just waiting for everyone. I'll go slow. Also, make sure that I'll be repeating the step if you're not following. Okay. So I just came to apps, go to API settings, then close this once it is connected. Then go to RC plugin wizard. So here just type 2D box culvert. Okay. Just type here as 2D box culvert.
Okay. Good, yeah.
You are able to see, then there will be
We've seen
option.
it.
Yeah, you can run that. You can run the command.
Yes, we have done that. Should we click on run?
Okay. So no
Yes,
problem.
that's what he said.
Yes. You're able to see access the plugin now.
Yes, we have.
Okay, perfect. Now go to run command. So once you go to run command, you can see this, you would be able to do it. You will be able to check it. So onto the top, there is geometry, carriageway, soil, temperature, and moving load, right? So these are the definitions that we have to do it. So you can see there is a model, there is a design, and there is a drawing option. Okay. So here you can enter what is the material. So it is M50. So you can give the property of material. Let's say I'm using 440. So as of now, I'm not going to input any sort of data over here, but I'm just keeping the same data which I'm using. So here I'm just keeping this as 0, then soil. So these are the steps that we have to do it. So you can enter what is the clear span, what is the clear height, what is the wall thickness, what is the slab thickness, right? What is the haunch top and what is the haunch bottom. So this data we need to enter. So what is the carriageway? So here you can see the carriageway width. Then there is the soil information. So the varying course information that you can enter. What is the subgrade modulus? So you no need to do it, but I am just explaining how we can do it. So I just want everyone to pay attention. So you can do it if you want it, but however, we are not going to use it for now, but I'm just explaining how the plugins is going to work. So you can see this moving load. So you can consider what moving load we have to do it. And after that, we can use this create model. So it will ask that if you have to create a new model or you just have to override the existing model as well. So now with all these details, the plugin is going to help a ready-made model with all the set of loading, support and boundary conditions onto your model. Okay. So now you can see over here. So I think it is taking time. So once the model is created,
Okay, hello, sir.
yeah, hi,
While
hi.
we're waiting for that, please can you just remind us of what you said yesterday about when we want to close the app? You said
Sorry.
something like we're not, there is a systematic way of closing it. Please, can you just recap on that?
Can you come again?
I said, yes, if you can help and recap on how to leave the app, as in when you're done with what you're doing and you want to exit or you want to close the app. There
Okay.
was something you were saying yesterday.
Okay. Let me explain. So, all right. So, my purpose was to just to showcase what is the new thing. Okay, let's now go with this. So maybe you can see onto your screen over here that there are certain plugins which are available, and also for you have installed it, right?
Yes, yes, I have.
Okay. Let me explain that. So just a minute, I'll showcase to you. So once have you able to open the Civil NX?
Yes, I'm
Oh, perfect.
already currently at where you are.
Okay, perfect. So now if you have to exit, so what you can do is you can just click on that particular cross command. So there is a exit that you will be able to see. So let me go to this part again. I'll explain to you. I'll just a minute. So once you connect this, so if you are running with any of the application, so in the within Midas, so let's say if you are running any plugin that you have, okay. So what we would be doing is if you have to cancel that or if you have to come exit onto it. So let's say I'm using this one for an example. So you can just simply put a cross over here, okay. You can just put a cross and exit the application. Okay, so once you run it, let's say if I'm running any plugin, what you have to do is you just have to go onto the top and click cross over here. You just actual demo.
Then they online.
Mute your mics, please.
Oh, wait. Wait.
Mr. BJB, can you mute your mic, please?
Yes, good morning, everyone. Sincere apology. So I've called the admin personnel so they will inform them now because the lecture is still ongoing. He is not aware that he has actually muted his mic. So sorry for that.
Hello, Engineer Yusuf. Can you come again?
Yes, I can
Hello,
hear you now.
Yusuf.
Oh,
Hello, Yusuf. Can you come again?
yes. We can't hear anything for
Oh,
some
you can't
minutes
hear.
now. Yes.
Oh,
Almost 10
sorry.
minutes. Almost 10
Yes.
minutes now. We've not had anything or seen anything.
About 10 minutes now. They've not.
Yes.
Nobody
Yes.
hears anything.
But it is on out. I'm not sure.
Yes.
Can you hear now?
Yes, we can hear you now.
Okay,
Very clear.
now
Yeah,
let's
but
repeat.
not the visuals.
Yes, and we
Vision.
can't see the screen.
Okay, so what I can do is let me turn on my camera better.
Yeah. Yes.
Am I able to see everyone?
Yes, yes, yes. I
Yeah,
can
yeah.
see you
So
now.
maybe, there will be some movement and you will be able to at least gauge if I'm talking or, doing some activities so that I'll be also ensuring at the same time. Yeah. Thank you. Thank you for that. I'll repeat
Yeah.
the steps now.
What about your screen?
Yeah. So make
We
sure
can't
screen is visible.
see it.
Is the screen visible?
No, no, it's not.
No,
Not
no,
yet.
Just a minute.
not yet.
I think it is
Uh,
because of the network. I,
Showing.
I I presume because of the network. I presume it is happened. So maybe you can check it once if you're able to see now.
Uh,
It's coming
okay,
up. Yeah, yeah,
okay.
we can.
It just came up now.
Okay, sorry for this inconvenience. Maybe I should have checked it. So yeah, let's go further. So I was explaining about the
Yeah,
thing which I had been taking up as example problem for today is this one, the 2D box culvert. So you can open the PDF. You can see the problem statement, everyone. I want to study every engineer to study the problem statement. What we are doing, I am going to explain it. So as you see, there is a clear
please,
span of the
uh,
box which is given. Yes.
please, question, please.
Yeah, please. Yeah, you can go on. Yeah.
Okay, okay. So this PDF that you are telling them that they can open, maybe I don't know whether the people present have it, but we that are connecting virtually, how do we have access to this PDF and all that?
Uh, it is shared in a group. Are you able to see the in a group in a this particular group? Uh, the workshop group. Can you just check? We have shared it. It is 2D box culvert wizard tutorial. It's over here.
Just give us a minute to open it, please.
No problem, no problem. You can open it. I request everyone to open the PDF. You can take your time and open the PDF. Have a look at a problem statement. Then we will start.
Please, is it possible to reshare it on the WhatsApp group? Because I can't
Okay,
see,
no
I don't
problem,
seem
no
to
problem.
find it.
No problem. I'll share it. Maybe can I will just send from another account like Mr. Engineer Lawal would share it. Uh, Maybe you can just have a look upon it. I've shared it over mail also. So what we are going to do is we are going to create a Google link in which I'll upload all the material so that it will be easy for everyone to have the access. Okay. So we will wait until you open the PDF so that we will go forward once you have the details with you.
We've opened it.
It's shared, right? Yeah. Okay, no problem. Okay. Yes, yes. I think it's shared.
Okay, yes, you've seen it.
Sorry.
Are you talking about this part, 5 meters?
Yes.
Say the road is about 8 meters.
Yeah.
Fine.
5 meter is a clear span. Clear span.
Clears.
Yeah.
Okay. There's the culverts.
Yeah.
Span to the culverts,
Yes.
which is the clear span is 5 meters.
Yeah.
No, I don't know this one. So does it mean you have to? So please, if you are talking, use your system. Make sure your system is on so that others will hear the question you are asking. So take it. Okay, you understand? Okay.
It's on, yes.
Yes.
Okay.
Get what you are.
So what I'm saying is that the box 5 meters span, meanwhile the road connecting to is about it's more than 8 meters. So does it mean that you have to construct?
Okay. What I'll do is I'll explain to the question what sir can actually explain. So I'll draw in a pen. I'll open in a pen so that it will be easy. So here you can see that, like what sir has been asking is the clear span, right? So what is the clear span meaning is, so once we have this particular box, okay, so imagine this is a 2D box culvert, okay, but however, we would be having a certain thickness of this box, right? I hope my screen is visible to
Yeah,
everyone.
it is.
Yeah, okay. So as this is my box, okay. So ignore the drawing, please. So now what we say is the 5 meter idealized span of the box is 5 meter. So what it means is we would be modeling with respect to the center line. So when we say a center line, so this is our center line, okay. So center line would come at the exact mid location of this point, okay. The actual center to center distance that we would be modeling is from this point to this point, okay, mid of this particular wall to mid of this particular, sorry, color is okay, fine. Different color, yeah. Okay. Can you see this center line? Yes. So actual length, what we would be modeling is this particular with respect to the center modeling. I mean, meaning is we would be having a certain thickness that numerically is something that will represent the section thickness. Maybe it is a beam, column, right? But however, when we are going to say what is the actual span, what we say is the span of the bridge is the total span. But numerically, what is the span? Yeah, it's a 5 meter, right? So in 5 meter, what we say is this particular span, center to center is our 5 meters. Clear, everyone? Now, what we have to do is we have to add this particular half of the depth of the column from one side to the half of the depth of the column from the other side. Okay. So it will be idealized span, which we say is the half of from both the sides is 350 by 2 plus 350 by 2, which is 5.35. So the total span of this would be 350 by 2. This is also 350 by 2. This is also 350 by 2. So this idealized span would be 5.35. Clear, everyone? Is
Yes,
this clear?
it is. Very clear.
Yes,
Yeah.
okay.
Just see the drawing again. This is half of the wall thickness. I mean, drawing would be not be that clear. Sorry for that creepy drawing. Yes. So here you can see this is the thickness which is being added as the half of the width of the wall from both the sides, making it as a clear span. Right? You got right?
It's okay.
Yeah. Yeah.
For the road is 8 meters, that's the very good.
Yeah, this is the clear span. Basically, what we have is the clear span. However, so this is something that we have, right?
Can't see something.
Excuse me, please.
So this is the clear span. Very good. Right? Good. Now, what we would be doing is,
Excuse me, please.
yes. Yeah.
I was going to think that the clear span is the free space, from the wall to the wall.
Yeah.
You understand? Then the
This is 350 by 2.
so yes, I was thinking it's from the
Now,
internal spaces in the internal spaces of the walls. It's 5 meters.
5.35 meters.
They are not pursuing.
I think we cannot use this.
You cannot use
Yes, they cannot have that.
Yeah, I think maybe the connection.
Why did you not connect it?
No, it's okay. I think everyone, do you have any questions so far in idealized span and what is the clear span? Maybe we can't, there is a projector over here, but we can't really showcase that. I mean, we can't connect that, it seems. But better I can try to explain it over here itself only.
But what I'm saying,
Yeah.
that the road according to the survey is 8.8 plus meters. So how does it now? How do you climb?
8 meter.
The window. The longitudinal.
Yes. It's a 2D. 2D. So in 2D, you will be having a single line beam. Okay. So if it is 8 meter cross section, if it is 8 meter, then it will come from 0
to
8 meters. And if you have the side walls, add by 2 from both the sides. So it will constitute the total wall thickness, right? So there is a question, if you understand, if let's say there is a 8 meter, okay, how we are going to add this? So we need to add the thickness of the wall. So let's say if your thickness of the wall is T, then T by 2 would be added to your idealized spine for modeling your end-to-end meter span. Clear, everyone? So this is the thickness. So it should be added.
Okay.
Clear? So yes. Now this is the clear carriageway width we have, then thickness of the crash barrier and the width of the structure that we would be having. Clear? Now, first of all, open the project. So save the project over here. So everyone just save the project with name as 2D box culvert. Okay. Give this as 2D box culvert. On page number 4, just everyone, please see the page number 4 to set up the unit systems. Okay. So unit system is something that you have to choose whether you would be inputting the data in meter, kilonewton, or let's say you are going to input in some other format. So that thing you have to select over here under the unit system. So go to unit system. We are referring to page number 4. Okay. Page number 4 of the PDF. The very first step that we would be doing is go to this particular option for changing the unit system. So in project, the very first step is project. Is everyone following? Please let me know. Very first we would be doing is the
Yes, I
setting
follow.
out. Yeah. Thank you. So very first step is the unit. Now why we are setting unit system? Because you would be having certain set of data to input. Now what you would be inputting is you need to enter the length in meter, force in kilonewton, temperature in Celsius. So that's where we have to just simply select as a unit system, right? So click on OK. After that, the very next step that we would be doing is entering the
There's a question, please.
yeah. I
There's
think
a question.
yeah, please.
Okay, the question I have, when we lost contact of your video, all right, we are still at the page where you were talking about the moving load, all right.
Okay.
So, how we navigated out of that place to now come to where we are now, whether we started
Okay.
afresh, is what we
No
didn't.
problem.
I didn't connect.
No problem. Just open the software and save the project now. So I'll explain one more thing one more time now. Open the software. Did you open the software?
Yes,
Okay. Now save it. So go to file, go to save
yes,
option,
yes,
right? And after
yes.
that, very first step that you have to do is go to project. The second option, you can
Okay,
see it under my screen, is the project.
okay.
And in project, there is a unit system option. You will be able to see there is a unit system. Click on unit system, select length, force kilonewton, and temperature as Celsius, and click on OK. This is the very first simple step to set out the unit system. Okay.
Temperature.
So if you are referring the PDF, come to page number 4 of the PDF. Okay. Come to page number 4.
Yes. Page number 4.
So once this is done, we'll go to the next step. Come to page number 5. Material definition. Come to material definition, the next step. Okay. So come to page number. Everyone, I request everyone to be muted. Unless you have a question, you can unmute and ask. So come to page number 5. I will explain how to define the material. So go to very first step. So here come to properties tab. So I'm explaining on page number 5, whatever the things that are there, I will explain how to define a material. Okay. I'm going to explain how to define the material. So I'll open the software, go to properties. So what you can do is you can just pay the attention how I am defining. Then I will provide you time to define from your end. Okay. So just see how to define it. So here you can just go to properties, go to material properties.
Please, can the admin help mute admin Akim Adiogun?
Can you just mute your mic so we can concentrate?
Yeah. I think someone's system mic is on. Please, everyone, I request those who are, not having a question, requesting to mute yourself.
And the host just help us mute him.
Now, we would be going with the very first
Please
step.
mute your mic.
I'm not the one. It's Akim Adiogun that you need to mute.
So let me mute all from my side so that it will be easy.
They should all mute their mic. We don't want them to be distracting. At least it's one person that's presenting should be talking. How are the mics even open? They should mute their mics.
Yeah, thank you. So yes, come to page number 5. We are defining the material properties over here. Now I will explain first how to define that. Then after that, you can do it from your end. Okay. So how to do that, I will explain. Come to add. So come to this concrete option. Over here, you can just go to this option to choose. Over here, if you can see, there are a lot of code to be defined. So if you see the type of design, there is a steel, concrete, SRC design. Then come to concrete, there is the code which you will be able to select. So maybe there is a codal standard that you have to follow, right? So maybe using the BS code, or let's say you're going with the Euro code. So accordingly, you can select it from the drop-down list. So if you're going to select the BS code, accordingly, the material grade which is available as per BS would be available into the material tab option. All right. So let's say if I'm selecting C30, so accordingly, all the properties over here as per the modulus of elasticity, Poisson's ratio, thermal coefficient, right, will be automatically considered. Okay. So now you don't have to do it anything over here. It is gray out. I mean, it is not able to change the properties. It is code based. What if you have to define your own set of material? So you can go to user defined and accordingly enter the data. Clear? Here you can go to concrete. Here you can go to this material definition. Okay, as per Eurocode, if you are defining, you can simply select the code and the DB, I mean the database. Meaning is the grade of concrete would be available in this particular tab. Clear everyone? So as per the code, if you see, there is a M35, which meaning that it is as per the IRC code. But here we are going to get through with the BS standards. Okay. So I hope everyone is here is adopting the British code, right? British standards. So accordingly, we will select with the BS code. So select the concrete. Here select the BS code and select C35 as the grade of concrete. Okay. So what it does is if you are not able to see the OK tab, see everyone, those who are not able to see the OK tab over the screen, use the minimize option left to the concrete where I am pointing. Okay. So you can see that you can use this option to see your OK tab over here. Just minimize that. Or else if you're not able to see it, what you can do is you can go to resolution settings. If still you're not able to see, there is other way to do it. You can go to this settings under the settings option, display settings. So under this, you can adopt the resolution of the screen. So make sure the screen resolution is standard every time you are using the recommended set of settings to use it, so that you're now you would be able to see the tabs. So basically this is supported with some graphics, so you have to check it that it is adopting the the correct resolution settings. So go to concrete. I'm using concrete again. So using the BS code, I'm selecting the grade as C35. Once you select the grade of concrete, you can click on OK. All right. You just have to click on OK tab.
Sorry.
Yeah,
Ask
please.
questions.
Yeah.
Now, a lot of people talk about grade 35, which means when you take it to the lab for crushing, the span should give you 35 kilonewton per
Yeah.
millimeter square, meter square. But generally, do we use C35 for culverts, or can 25 be okay?
Even like for stronger culverts, if the demand is more for the design, we go with C35.
Come again?
If based upon the span that we have, let's say if we have a greater span, let's say around 8 or 9 meter, then we usually go with C35. For minor span or a smaller span, we go with C30, C25.
Because hardly, in practical sense, you make use of C35. What is left? I mean,
Yes, C35 majorly is being used to account for, as we see today, the seismic codes have become more strict in the sense that if you see the British standards also, they're adopting C30 as the minimum grade of concrete.
hmm,
Just because their guidelines for the seismic criteria has changed.
we don't have earthquake in Nigeria.
Yes, but for BS, we are referring to for this now, we can go with C35 or C25 as well. But majorly, it is based upon the requirement of the span that you are going to design. Yeah. Or the concrete material that you have, based on the ability. Right. So we are taking C35. Are you able to define, everyone? I will give time to define. So you can see the step on page number 5. You can see the step on page number 5.
Yes, we've done that.
Yeah. I'll wait for everyone to define, then we will go to the next step. So everyone just check if you are able to define
So
material.
so so I have a question.
Yes.
So when we get to that C35 for BS code, the weight density that automatically gets computed is 23.6.
Yes.
However, in our normal practice, which also conforms with what's in the material, we are having the weight density as 25 kilonewton per meter cube. So now,
Yes.
if this discrepancy is accumulates over your multiple volume of design, won't it have any effect? Like I'm having
Yes, it
23.6 when
does.
in reality it should be 25.
Yes. So those modifications are available. How it can do is, there is a very simple thing to do it. What you can do, you can just go to select none. Now you can see you can modify the parameters if you don't want to go with the codal provisions. So let's say if you don't want to adopt the code uh, criteria, what you can do, you can just simply select the code to none. And now you can see I'm adopting this as 25 kilonewton per meter cube.
Okay.
So that those are the options you can which you can do it. Right? Am I
Okay.
answerable to your question? Yeah. Okay.
Yeah, yes, you've
Yes,
answered it.
even in our codes also, in Indian codes also, there are provisions where certain codes suggest to be used as 25, and where we can certain codes suggest that it is to be, I mean, the railway code suggests that it should be 25, whereas the highway standard requirement is 23.6. Okay, but
Okay.
nonetheless that you can go to this selecting the code as none, then program will allow you to modify the properties. Okay. So it will allow you to modify the properties where you can change the properties. Clear? Okay. So,
Yes, it's clear.
okay. Now, thank you, everyone. I hope it is going slow. If you have any questions, please let me know so that we can discuss and accordingly move forward. Okay. So next thing is going to
Please
be,
excuse.
yeah, please let me know.
I can't adjust my display to press OK to enter OK. I can't do that.
Yes, you can do it. You can press enter as well.
I can press enter.
Yeah, you can do it.
Okay.
Yeah.
Let me give it a try.
Yeah, sure. So maybe, even if you're going with entering the part, you can just use this tab option. So unless it go to OK, or other way, like if you have to define it, the material, you can define it using the table also. Just see how I'm doing it. Go to works tab. On to the left, there is a very simplified works tab where you can see the model definitions, what you are doing. Okay. So let's say if you're going to define from the works tab, there is a material. So here you can see there is one material. You're able to see under the works tab, go to tree menu. Under the tree menu, there is a works option. And over there is a material option. Clear? So under material, you can see that there is a C35 defined. Else, if you don't have to define in that way, go to right click onto this material option. You can add the material, and you can I mean, or else you can go to tables also. In tables also, you will find this material definition. So under properties, there is a material properties. Under the tables, if you have to define it through the tabular format. So here you can define the parameters and you can close it from here. So let's say if I have to define with the code. So what you can do, you can select the code. So let's say I'm defining using BS standard. So accordingly, you can select what is the name, what is the grade of concrete. Okay. So based on that, you can simply do it from the tabular format as well. So meaning is you can define the material from graphical interface or through the tabular results as well. Okay, clear? So I'm deleting this now. How to exit it? Click onto this. I'll just delete the data. As I don't want this data, and I will just click it from over here. You can see the close tab from the top. So once you click on close, you can see one single material is defined now. So now next, come to the next step. Come to page number 6, everyone. Come to page number 6. Yeah. So now we are going to enter the set of data over here. So open this particular software, go to the structure tab over here, go to the RC frame option. Okay, so there is a specific wizard for that. Okay, so we are going to model through wizard the geometry, and here we are going to select 2D box culvert. Okay, select 2D box culvert option over here. Select 2D box culvert. Okay, come to page number. I'm again repeating, come to page number 6. So everyone just follow from here what we are going to enter. Okay, so here we are selecting the grade of material. Okay, so that is the very first thing. Now, what is the span that we are going to enter over here? Can anyone answer what would be the span now? What is our span? You can see the image. You can see the image and answer. It's very easy. In image onto the top, what is shown?
Span would be 5.
Yeah, it's idealized span, right? So it is 5.35. So whenever you are entering the span definition, it has to be the complete span, not the center line span. That is the representation. That's, yeah. Okay. So the image representing the infinite spans. So those many spans that you have to model would be into the input of the span definition. So this is 5.35 meter. If I have a multi-span, how am I going to enter? Let's say if I have two spans. So how I am going to enter? I'll enter this as 2 at the rate 5.35. Clear? So, but now I'm entering this as single span. So it will be 5.35. Okay. Now T1. So if you go to this T1, so T1, what is the T1? It is the thickness of the top slab. Yeah. So 350 mm, 350. So you can see the thickness of the top slab. So it is 0.325. It's already given, right? So it will be 0.325. So again, in the same tab, you can see it is 0.325. So T1 would be 0.325. Clear, everyone? Okay. Now T3. So what is T3? Can you see the image? So T3 is the, what is T3? Can you find it, T3? It is the
Wall thickness.
wall thickness, right? So wall thickness is 0.35 again. Wall thickness is 0.35. Then T4. T4 is your bottom wall thickness, which is again 0.35. 0.35. T3. T3 is the onto the last wall thickness over here. Thickness of the wall. Maybe in laptop you would be able to better see it. Yeah, in mobile it might be not that convenient to see. Yeah, yeah. So yes, now coming to the next is entering T4. Now A1. So A1 B1 is the haunch height and depth, which is 0.3. So I'm going to enter A1 as 0.3. A3 would again be the top haunch height at the bottom, which is again point. So A3, we don't have bottom haunch, so it will be 0. So I'm going to enter this as 0. B1, so as you see, what is the B1? So B1 is nothing but your haunch width, right? So it is B1. So again, this is 0.3. So it is 0.3 by 0.3. Haunch height depth is 0.3 by 3. The slope is 0.3 by 3. Okay. Then we are going to enter B5. B5 is also 0. B5 is something that we don't have currently for the bottom haunch. So it will be 0. H1. H1 is nothing but the total depth of the culvert from the top to the bottom. So which is 4.175. Okay. So we are going to enter this as 4.175. H2. H2 is the thickness of the soil. I mean, the soil which we have. Okay. Which we are entering as 0.065 mm. I mean, sorry, meter, not mm. So it will be 0.065 at the both the ends. So enter this as 0.065, both H2 and P value. So we are referring page number 6 for those who are following from PDF. I request to check it from page number 5. Sorry, 6, page number 6. So we have entered material, we have entered span, we have entered the thickness of the top slab, bottom slab, haunch height, haunch depth, and the thickness of the soil layer and the pavement thickness. Clear, everyone?
Yeah.
We're clear. All right, perfect. Now let's go to the second step. Come to page number 7, everyone. Come to page number 7. So we are now moving towards the transverse definition. Okay.
Uh,
How to define the
please,
transverse definition? Yeah, Engineer Solomon.
okay, so my question is these values that we are imputing, all right, they are just given to us like T1, T3, and all that, T4. But how do we generate them ourselves in case we
Okay.
want to do a raw design?
Okay. So basically, like once for generating a design or setting up the parameter, we have to do a certain preliminary study, right? So for this particular box culvert to be designed, we have to first upon fix the span. Then we have the depth. So span to depth ratio, generally thumb rule is adopted. And based on that, we are trying to fix the cross section. So that is how we generally do it. Now, the workout example which you are seeing is the example problem. I mean, this is the case study problem, not the random example. It has calculated its D1, D2, T1, T2 parameters already. It has been designed. So is the reason why we are having this part. But let's say if you have to design, we need to see what is the span that you're going to design. So for that, we need to do a preliminary study where we would be calculating the what is, the level of the or the depth of even if it is a culvert or an underpass, maybe the depth of the underpass we need to design. What is the typical railway bridge? If it is underpass, then what is the depth of the soil that we have? So those parameters we need to consider for the preliminary design. Again, there are some empirical formula. If it is an underpass for carrying your water or any fluid liquid, for those, it will be a different criteria for the design, right? Everyone following?
Yes, I quite understand what you just said.
Okay, perfect.
Okay.
So, all right. So now next go to the next step, the transverse definition. So go to transverse definition. Over here, we will be selecting this as, the type 1. So we'll go to transverse, type 1, B3 as 0.45. So we'll select this as 0.45. B4 as 0. B5 as 8.75. B6, again, you can see the B6 is the width of the walkway, which we don't have. So we are keeping as B6 as 0. B7 is the width of the crash barrier, so which is 0.45. So B3 and B7 are nothing but the width of the crash barrier, for which the width is same, which is 0.45. Okay. Now coming to the supports of the culvert, we have modulus of subgrade reaction. So what is the modulus of subgrade reaction? It is nothing but, as can anyone explain from the participants, what is the support or the foundation for culvert? Can anyone explain what is the general foundation that we are adopting for culvert?
A
We're looking
raft,
at raft.
like a raft slab.
Yes. Again, any more answers?
Or sometimes it's strip footing.
Flat slab.
No. So ideally, if you see, box culvert are resting on soil. They don't have foundation. We are not designing any foundation for box culvert. They are simply resting on soil, right? Have you seen ever, like maybe in your city or in your, when you travel, there are some underpasses. We don't design any specific foundation for that.
Spring support.
Yes, that's very correct. That is very correct. So what we have to do is we need to identify what is the type of soil on which it is going to rest. These are minor bridge structures. So no foundation design for this. They are going to rest directly on soil. So for soil, what is the type of soil and what is its subgrade modulus value, which is nothing but the spring constant or the spring value which we are going to enter. Clear? So we are going to enter
Uh,
this as
please,
7630, which is again,
please.
ranging from the silt soil or the clay soil, right? So I'm going to enter this as 7630.
Please.
Yes, Engineer Solomon.
Yes, how do we get to this transverse session after we came out from the
Yes.
after
So
we came out from the
go
structural tab?
to go to longitudinal. Here there is a transverse tab.
I mean, after we came out from the structural ROC frame.
There is a transverse right over here where I'm pointing the cursor. You can see the cursor.
I'm not even seeing the tab, the open tab. I mean, how we got to this tab that's open now.
This support of the spring is not able to see.
I mean, the entire tab that is pop-up window that is open. How did we open it to have this longitudinal and transverse?
Okay. Go to structure, and over here there is a RC box culvert. Go to RC box culvert. Go to structure. There is a RC box culvert.
Okay.
Yeah.
Okay, I got it. Thank you.
Yeah. Okay. Now enter the subgrade modulus as 7630. enter what is the length of the elastic link, so which is 1 meter. So we'll keep this as 1 meter. Now come to the loads. Come to the next step is loads. Okay. So under loads, we have these options. So come to the open the PDF. Come to the loads. Come to page number 8. Okay, I will wait for those who have not completed until transfers tab.
Better, let's come up there.
Okay, no problem. No problem.
Yeah, sorry. Well done, sir. While we wait, please, can you shed a little more light on how to calculate coefficient of subgrade reaction for soils? Thank you.
Okay, okay. So basically, it is based upon the geotechnical data. Geotechnical engineer goes with the testing. So there is a testing result that geotechnical engineer carries, and based on that, he is calculating the subgrade value. Okay. So this subgrade value is derived from the empirical equation.
Okay.
And generally for most of the soils, it is having certain range.
Mm,
Okay. So that value we are adapting over here. So now if you
okay.
have to find these values, okay, I'll just quickly describe where you can adopt this.
Okay. Okay.
So let me show it to you. If I have that particular table. Yeah. So here you can see there is a type. You're able to see the PDF?
Yeah, I can see.
Yeah. So you can see for soft soil, it is ranging from 12,000 to 24,000 kilonewton per meter cube, right? So these are the range of values that we have for different type of soil. But if you have to exactly enter, it has to be from the geotechnical engineer. We have to get the value. Clear?
Okay. Clear,
Now
clear.
you can also get this
Can I
PDF
just
analysis reference. Analysis reference PDF would be there in the C drive, which you can open. Yeah, yeah. If someone was asking a question, please
yes,
go
yes.
on.
Let me just point him also to a text.
Yes, yes.
Foundation Engineering by J.E. Bowles. The
Yeah,
formula
that
is
is
there.
very famous book. Yeah.
Yes, yes. In some of the software, that formula is adopted, like in
Yes.
Engine.
Yes,
So,
that's right.
so if you go to J.E. Bowles, you will see it there.
Yeah.
So if you know the bearing capacity, you can easily calculate it. It's based on a penetration of about 20 millimeter.
Yeah,
Do you understand? Then there's a factor of safety.
that's right.
So you just check J.E. Bowles.
I hope there is a clear explanation on that.
It's clear.
Yeah, perfect. Thank you. So now let's.
Okay, sorry. Addition to it, the K value,
I think yeah, there is one more thing. Yeah.
the K value is basically saying the the weights that can cause a particular settlement in an area. So, like the last speaker said, if you relate the geotech findings, you understand, and from the geotech findings, you can actually be able to determine the weight that can cause a 1 meter of
Settlement.
settlement.
That's very correct. Yes.
I don't know if that adds to the knowledge.
Yeah, yes, yes. It is definitely.
This 25 mm penetration.
Yes, penetration. I think there is a limit. Yeah, 25 mm is the penetration limit. Yeah.
Is penetration is the bearing capacity divided by 25.
Yes, that's correct. That's correct.
Then divided by 3. 3 is the factor of safety.
That's right. So maybe like some other code, some other provisions would be different. But however, there are certain limit where we can, just have to check the settlement limit for carrying out the pile bearing capacity. I mean, the capacity of the subgrade value of the soil. Clear, everyone?
Okay.
Now let's move towards the next part, which is the loads. So we'll go to the loads. So come to page number 8 of the PDF. Come to page number 8 of the PDF. So now we will be going to the loads definition. So over here, the very first step that you will be selecting is the definition of the code. So for now, select just the load combination as per IRC 6. Okay. Since we are not going to adopt the load combination, but just select for the reference as IRC 6. Now, as per the table, we will be considering self-wet, then we'll be considering the pavement. Okay. So the wet density for the pavement is 22. So we can select this as 22. Soil wet density would be 20. So I select this as 20. Then 5, which is the internal friction angle, it would be 30. So I'm going to enter this as 30. Surcharge would be 0. So I'm going to enter this as 0. Right? Barrier weight, I'm going to consider as 11.25 kilonewton per meter. So over here I'm entering as 11.25. There is no additional load or the sidewalk, so I'm not going to consider this for my example problem. So I'm going to remove this sidewalk. Okay. Just enter self-weight, pavement weight density, soil weight density, the internal friction angle, and also the barrier weight, which is 11.25. Over here, how you can calculate the weight of the barrier? We already know what is the total cross-sectional area of the barrier multiplied by weight density. So you will get what is the actual load per meter for your crash barrier. Okay. So now once you enter this data, you can click on OK. So you can find this OK tab.
We have the temperature gradient.
Yes, temperature gradient we can enter. So for now it is 17.5. So I'll enter this as 17.5. Only the gradient value we have to enter rather than the system temperature. So here I'm going to enter this as temperature gradient as 17.5. Okay. So once you enter this,
Okay.
click on OK. So once you enter this, click on OK.
So when we have a surcharge of 0, that means the pavement is resting on the top slab of the culvert.
Yes, yes, yes.
Okay.
Yeah, that's right.
Yes. That's
Sorry?
that's it for the
17.5, yeah.
That's high now.
75 degrees Celsius
That is the difference, yeah.
between the top
Top slab,
bar
bottom
and the
slab.
bottom.
Yeah.
75 is almost like boiling water.
17, 17.
Pardon?
17.
Oh, 17. Oh, okay.
17, yeah.
All right. Okay. Thanks.
Is everyone able to get the model?
Yes, but at this point, I'm having the model I'm having elements, having a comment that elements are overlapped at the same
Yes.
location. Is it okay? Okay.
Okay, no problem. I'll explain how to do that as well, how to remove that error. That is very good observation you have done. So maybe what I'll explain how to remove that, because maybe earlier you could have generated some of the elements, but no problem. So what you can do is you can come to this option. So if you have to simply check if your elements are being overlapped or not. So here you can just come to this point. So if you come to node element tab, for those who are getting the error as duplicated elements or overlap elements, come to node element tab, come to check structure option, and over here use this remove duplicate elements. What software will do is it will automatically check for the existing, if there are some overlapped elements, it will automatically check if there are, and it will delete the overlapped elements. So this is one of the function where you can easily cross check if you have duplicated or mistakenly assigned the same element on a beam or a column. Okay. So you can use this option. So you can go to node element tab, go to this particular option called as check structure, and use remove duplicate element option. Clear?
So how do we manipulate the model to view it properly? Like to rotate and check in different directions?
So see, you can just use the mouse. So you can just scroll up and in, like you can pan the model as required. And over here, there are the display option also. Like if you have to see the top view, if you have to see the mid view, or let's say you have to see this isometric view, that can be checked over here. I mean, you can just simply roll it the model as required. So zooming view is on to the right top. Right top, you will find the options to navigate to either from X view or let's say vertical view, I mean the top view, or from the right.
Hello. Hello. Are you in class? Are you in this class? Are you in this class?
So everyone just check into this data that you have got. Into the tree menu, you will be able to see what is the beam, right? What is the properties, what is the section it has generated, right? So there are supports, then there are points being support. Now, how to see it is assigned on model, okay? So you can just right click and you can just use this display option. So as you can see, these supports are assigned, then there are elastic link which are assigned. You can right click and you can use this as display, right? Even for the loads also, any parameters you have to check it. You can go to this particular part, right click and make it display. Okay, so you can just use this display.
So can you come over again?
Yeah. So if you have to see any parameters which is assigned onto the model, then here you can just use it, right click onto any parameter. So let's say if I have to see the elastic link, you can right click and make it display or undisplay. Okay. So once you click on display, you can see your elastic links would be visible. Correct? Now if I right click and make it undisplay, it will go away. Now, if you have to see what values are being assigned or any point, you have to change it. Okay. You can right click, go to tables, and you can see the values which are being assigned. So tables can be seen just by right clicking on right click and getting into the tables. There will always be a table option. So you just have to right click and click on tables. Okay. Just right click and click on tables. So from here also table can be edited. Okay. So for everything we have the tables over here. So even if you have to see the loads also, right click and make it tables. Right. So these are the loads which you can see in a tabular form. So both graphical and tabular checks can be done from this particular tree menu. We are able to see how to use the tree menu, everyone. Please note, this is important because every other definition that you are seeing or you have to change can be done using the tree menu only directly. Right from the tree menu, you can change the definition. Okay.
Yeah, my model is appearing as a mesh. How do I make it
Yeah.
appear rendered,
Yes, for that, what we have to do is we can go to this view tab. Under the view tab, there is a hidden option. So you can see once you click on hidden, you will be able to see the thickness. Once you make it off, you can see the actual line model. Okay. The shortcut command for that would be over here. Like there will be a shortcut command which would be present. You can also check it, or else you can directly go to this view tab. So under the view tab, there is a hidden option called as hidden. Is everyone able to get it? So there is a hidden tab. So you can render the 3D view also. Oh, you want to break? 5 minutes if you want. Okay, we can wait. No problem. No problem.
Maybe asking.
No, no, I think we are continuously going. Yeah, yeah. I can. Okay, we can wait for 5 minutes before going towards the next step. So, yeah, yeah. It's better we take 5 minutes.
Yeah. Yeah, let's okay. Um, link of the box.
Can we add them to the can we can we add them to the group? That's what I yeah.
So maybe we should split it because I'm breaking the race. Very square that, no? Yeah. So maybe we can, next one.
Yeah, window.
Well, let's see. On the other two.
Okay, so let's continue from here. Okay, so we go to the next step. We go to the next step. Come to page number 12. Come to page number 12. So we would be starting from page number 12. Come to page number 10. Now we will see the loading. Okay, so we'll create the load cases first. So to create the load cases, please come to page number 10. Come to page number 10, how to create the load cases. So we are now moving towards the loads. Page number 10. So come to this particular load definition. Static loads. Okay, so here there is a very first option as creating the static load cases. Is everyone able to see?
Yes.
So we already have dead load, temperature gradient, earth pressure, then shrinkage. So from where this load came? Because we have defined it using the wizard. So automated wizard loads have been incorporated. I mean the loads have already come directly. Okay. So now what we would be defining is SIDL over deck slab. Okay. So we'll give this as SIDL over deck slab. Again, the type would be dead load of components and attachment. So it will be dead load of components and attachment. Click on add. Okay. SIDL over deck slab. Then we'll also create the earth pressure load case. So add one.
Please, can you take that back? Take that once again.
Yeah, please, no problem, no
The
problem.
last.
I'll explain again, no problem. So come to loads, come to static loads, come to static load cases. Okay. So now if you see, we already have dead load, temperature gradient load, earth pressure load, and the shrinkage load. Okay. So further, what we need to add is on page number 10, we have given the live to be added. I mean the load case to be added, which is SIDL over deck slab. So what is SIDL? It is superimposed dead loads. Okay. It is superimposed dead loads which we are considering. So we'll give this as SIDL, which is the short form over the deck slab. Okay. So here I select as dead load of components and attachment. I'll select the type. So type would be under the load type, right? So it has to be dead load of component and attachment. So now what is the significance of this type? Because whenever you are going to make the load combinations, the factor of safety which we are going to consider would be based upon this load type. Because if you see the factor of safety, I mean the load factor which is there for varying course or the component is different. Okay. So for that, we have to take care that it is correctly selecting into the appropriate load case. Clear? So select dead load of components and attachments. So click on add. Yeah, Engineer Solomon.
So please, just on this place where we are now, where we are having these load categories, I noticed that in
Yes.
my own case, it was duplicated like from dead load to shrinkage
Yeah.
load. Then it was also
Yes.
duplicated again in my own
Yes.
case. I don't know if it's because of the way modeled earlier. So instead of having 1 to
Maybe,
5, I have 1 to 13.
no problem. You can delete. You can select in this way. You can select the load cases in this way and you can press delete onto the keyboard.
Okay.
Maybe it could have generated, I mean, the wizard could have been generated 2 to 3 times. So is the reason why the cases are appearing, but no problem. You can just select in this way, press delete onto the keyboard. That is how you delete the
Okay.
load cases onto the keyboard. Okay.
Okay. Thank you.
Thank you. Yeah. So now coming to the next part, I'm referring to page number 10. On page number 10, we are applying this as SIDL over DexLab. So we'll go to static load cases. We'll apply this as SIDL over DexLab. So again, I repeating what is SIDL? It is nothing but your superimposed dead load. So whatever the dead load due to your maybe uh, wearing course or some finishing load you have, that will be considered under the SIDL category or superimposed dead load category. Okay. Select the type as dead load of component and attachment. Click on add. Okay. Select the type as dead load of component and attachment and click on add. Once you click on add, the load case would be added. Clear? Yeah. Yeah, it can be anything like wearing course. Wearing course, the one which we have. Let's say if it's a underpass load.
This is why you are talking.
Okay.
Not only your phone.
Yeah.
That others will know which
What's question being asked? Yeah, that's
Okay,
right.
what I asked is that
Yeah.
what do you mean by superimposed dead load over dead load?
So over dead load is nothing but is structure has its own weight. The slab is has its own weight, right? So those will be automatically considered. But now, let's say if there is a varying course, if there is a road which is going from the culvert, the varying course load we are going to consider as the static dead load because it is going to be there, right? So that is nothing but your superimposed onto the culvert, which we haven't considered anywhere. Correct? So that will be my
Okay,
addition
dead load is dead load. When you now have a superimposed dead load,
because it is addition to the dead load.
so what's the practical?
It is a physical, I mean, practically, if you see, let's say if it's a table, it is designed for some load. But now I'm going to add some flower pots or something onto my table, but it will remain throughout the this structure. So
Generally, they are insignificant.
yes, so that's the reason why I'm telling that this is superimposed load, which is additional load which is coming up onto my design structure. Right? You're getting? So that is nothing but your superimposed dead load.
Mm.
Okay. All right. So now moving to the next part. So come to page number 12. And also one more load case. Sorry, everyone. We need to add the earth pressure load also. So select this as earth pressure. And again, this type would be earth pressure itself only again. So select earth pressure, click on add. Okay. So add these two load. One will be SIDL over deck slab, and next would be your earth pressure load. Okay. So now come to page number 12. So create these cases, and then we'll move towards the next part. Okay, so now come to page number 12. Now we'll see how to assign one by one the loads. Okay. Now generally what type of load we assign, it is onto the beam. It will be point load, it will be beam load, right? If there is a horizontal load or there is some kind of uniform load, that will be assigned in terms of elemental beam load. Okay. So how to assign that, I'll explain now. So everyone just have a look. So maybe, you can just see what I'm doing. And after that, you can just try it out from your end. Okay. So here I'll just go to this particular case as load. So I hope everyone has created the cases, and then we'll go to beam loads, beam load option over here. Okay. So under the beam loads, you have elemental beam load. Then select this as surcharge. Or let's say if it is creating, we are going to have a earth pressure load. Okay.
Sorry, sir. Please, can you come again?
Yeah, no problem. Now we are going to assign the elemental load. We are going to see the definition of elemental load. Actually, it should be a surcharge load of the earth pressure, but we have created a simple case of earth pressure. Okay. So for that, go to load, go to static load. Here we have beam loads, and over here we have elemental loads. Okay. So under elemental load, we can select the load case as earth pressure. It is surcharge load that we are assigning. So earth pressure surcharge. And then here the type would be uniform. Then further, we are going to assign the direction of the assignment would be in the direction of global X. How to determine the direction of application? So here you can see this is my X, longitudinal X where I am pointing the cursor. Transverse in this direction would be your Y. Okay. And vertical is your Z. Right. So now my load application for the earth pressure surcharge would be in this direction. Okay, so it is the global X. So select axis as global X. Clear? Now, after that, we need to assign what is the intensity. So intensity would be 12 kilonewton per meter. See the unit, it is 12 kilonewton per meter. So how to assign that, I'll explain now. So once you come over here, before you apply it, it is very important to select where you are applying the load. Whether it is on top element, whether it is on side element, or whether it is onto the bottom elements. Clear? Now see how I'm going to select that. So I'm going to view tab. Here I'm going to use select option, and here I'm going to use select by window. I have to tell the program, right, which elements I need to select. So for that, I'm going to use this select by window command. I'm going to choose the element in this way. So I'll remove this hidden tab. So basically it is recommended that you remove the hidden tab, select the line element in this way. So you have to make a rectangle in such a way that the requested or the assigned element has to be in the box. So let's say if I have to only select the walls, the rectangle should only include the box. Here, please make a note of that. I am going to select the wall. So it has to be in the box. Element has to be in the box. If you are selecting from the render view, it will not be selected every time because you have to include the thickness also. So because see, what is the difference of selection? I will explain everyone. Please have a look. Over here, when you select by window option, okay, when you select left to right, I'll just turn on the node number also for easy reference purpose. So if you have to change any of the display settings, so what you can do is you can go to this view tab. So there is a display. There is a display option over here. You can use this node number option. Okay. So now when I'm going to select from left to right, not node number, sorry, I'll turn on the element number. So I can go to element. I will go to element number. You don't have to do it. I'll just have a look over here, the selection options which are there. So when I say left to right selection, so you can see that my rectangle is cutting only element number 4. But actually, the end of the node of element number 4 is not included within the group. Okay. So as you can see over here, when I'm doing the selection from left to right, my element number 4 is not totally included into the group. Clear? It is just that it is just touching the element number 4. So element number 4 would not be selected. However, when you select from right to left, when you select from right to left, any corners of the boxes which are cutting the element would get selected. So you can see over here, element number 1, although its node is not being selected, it will get selected when you just use the right to left selection. It is same like any of the CAD that you will be using, right? The tracing left to right and right to left selection. Clear, everyone? Is it clear?
Okay.
Yeah. So now for here, I need to use the sidewall elements. Okay. So for sidewall elements, you just have to select in this way. Okay. And then click on apply. So you have to select one by one. So because and this particular wall, it will be from left side. And when you select from the other side, it just have to be negative. It should be in the negative direction. So I'll select -12 and click on apply. So everyone just do it from your end, following the steps from page number 12 and 13. The two steps are given which I have done. So just follow one by one. I will wait for now so that you complete until this particular point. We complete up to page number 12 and 13. Once you complete, please let me know. Then we can move ahead. You're able to download, sir? Yes, no problem. Phone number, email, you can go on typing. Okay, so everyone done up to this part? You want me to repeat this step? Okay. Let me do it. How to assign the elemental load? Please have a look. So here, just see over here, I'm going to assign it one more time. So come to load, come to static load definitions. Over here, there will be option to assign the beam loads. So select elemental beam loads, select the pressure as earth pressure. And here, if you see, there are a lot of other options to assign. Like say, there will be some concentrated moments, concentrated loads to be applied. So these are some options over here. So we are going to put with uniform loads. So it will be direction will be global X. Now what is W is 12. Here we don't have to change X1 and X2. Okay. So remember X1 and X2 is nothing but the distance of the load application onto your element.
Yeah. Sorry, sir, you're a bit fast, please.
Sorry? Hello?
You're a bit fast, please.
I have been fast.
You're a bit fast, please.
No problem.
Yeah.
You want me to do fast? Fast.
Slow the pace down. The pace
I
is
think he
Okay.
wants you to slow
No, I'll
down.
do it. I'll do it. Okay.
All right.
Shall I inform now? Later, right? Okay. I'll slow it down. No problem. So again, have a look. I'll repeating again. So come to static load, elemental beam load, come to element. Okay. So here it will be elemental beam loads. Load case will be earth pressure. Then type would be uniform loads. So again, I'm repeating, it should be earth pressure. Don't have to select any load group. Options would be add. Load type would be uniform loads. And the value of the intensity would be 12 kilonewton per meter. Okay. The value would be 12 kilonewton per meter. Now, how to select that? Come to this particular view tab, go to the selection option, select by window. Here you will have the option to now once you enter the data, you need to select on. We need to tell the software on which element we have to assign. How to do that? Use the selection tab, select by window option. Here just select this wall element. Okay, only from one side. Okay, first select only from one side and then click on apply. So direction, we are remain with direction. So select global X. Okay, even if you assign it wrong, how to do it? You can find this undo command also or the control Z. Okay, undo redo command, you can do it. But make sure you are using it wisely because sometimes you might, come up with more steps and you can undo lot of steps. It is control Z and control X, the same which we work using, any of the, uh, programming applications, control Z to undo the part. However, make sure you are using it in a this way. Here there is a shortcut. You can see this is the list which you can find it. Okay. So there is a list where you need to perform the undo operations. Where if you have to simply undo anything, you can just right click and click on back, undo it. But make sure you are not doing too far because sometimes you may lost your data or sometimes you may lose your data. So just click on apply. Select this, give the negative value. Why negative value? Because it is in the opposite direction of X. So when you apply the load, so everyone, are you able to follow why I'm giving positive or negative? So over here, if you see this is my X, Y, Z, right? So this is my X, Y, and out of the plane would be my Z direction. Correct? Are you agree? So when I'm going to give loading in positive X, so all the load would be positive. However, when I'm going to apply the load in the reverse direction, the value of the load has to be negative. Now, if you see, I am going to apply the load in reverse direction, so it will be minus 12. So click on apply. Clear this, everyone? Please do it. I will wait, no problem. I will provide my time to do it. Because this is something, if you do it, you find some mistake and you can learn from it.
Excuse me, please. Excuse me, please.
Okay, just do it. So you can just go on creating the load case. Is this done, everyone? The earth pressure load is done.
Yes, but before then, there's something that I didn't get.
Yeah. Please go on.
On page 11. Page 11 now.
Okay.
Yes. How you right-clicked on the dead load,
Yes.
element beam loads.
Yes.
And then you arrived at the tables and made this and changed these load cases. Can you just go over it again, please?
Yes. So what we have to do is, I was coming to next part onto that. What we have to do is, if you see, I will close this. all the elemental loads. If you right click onto this, go to table, all the elements are included under one category. Okay, under the dead load. So what we have to do is we have to assign into surface code as well, because what it will do is it will create the loads for dead load and surface code in one category. But however, it has to be separated. So how to do that is using the drop down list. Okay. So how to select that or how to change that is something with respect to the value. So you can see over here there is two values. One is minus 1.30 and second is minus 2.33 for the same load case. Okay. So what we have to do is we have to change it to surface code, or we have to change it to this particular, sorry, over here SIDL over DexLab. Okay. We have to change the load case, meaning that whatever the lead cases which we have seen, because surface load we have already assigned in this particular category. So whatever the value we are seeing under this table as minus 2.33 is actually coming under the SIDL load over the DEX lab. So you can see the element number is 1, but one would be one category of dead load, and for the same element, one would be under the SIDL category. Is that clear? So we have to do this particular step over here. So again, this will be dead load, and again next would be your SIDL over DexLab. Dead load and SIDL over DexLab. So likewise, we have to change it over under this particular tab. Clear? For all the 7 elements, we have to change it under this category. So one would be dead load, and second one would be SIDL over DexLab. How I determine? Because if you see, the dead load is assigned in both the cases as same. So the value is minus 1.30 and second one is minus 2.33. Okay. So change it to SIDL over dead load. So whatever you are saying is on page number 11. You can follow from page number 11 also.
Okay.
Excuse, please.
Yeah, please.
How are you able to get the table?
Okay, I'll explain. To get the table, come to tree menu. So under tree menu, there is a static load option. There is a static load option. So under static load option, you can see this. You can find it. You can double click onto it so that it will expand. You just right click onto it and click on tables so that you can find anything, whatever you have defined in a table of form. Clear? If you have to close the table, there is a small cross option over here. You can close that and you can come back. Now we are going to go with the analysis. Okay. So for those who have completed the loads, go to analysis and perform analysis. Use perform analysis option. We are going to run the model now and see the results. Okay. So click on perform analysis option. Is everyone with me? Please let me know. Please let me know if you followed till this part. Please complete up till this part. So again, go to analysis. Use the perform analysis option. So everyone completed up to analysis. Make sure you are having this message. So once you get this message, it means that you have successfully run the analysis up to this part. Then we will go to results. So first, the very first step is the application of the results. So how we are going to get with the load combination is, you can click on load combination, go to concrete design. So here you can use this auto generate option. So what auto generate option does is, it will create all the possible load combinations as per the, can you just mute? Uh, it's echoing, it seems. Yeah. So you can just select any of the load combination over here. So what it does is, it automatically creates the possible load cases for strength and serviceability. So you can see why my voice is weak going. Is someone turned on the mic?
So a question.
No problem.
Yeah.
Yeah.
All those your superimposed loads that you are inserting now, are they constant? Are they fixed?
The load cases?
Yeah, the superimposed load.
Yes, these are fixed cases.
Okay, so the values are already fixed.
As in, I didn't get. Oh, fixed as in?
Pardon?
I didn't get exactly your question.
My question is, I
I
noticed
think he wants to know.
7.2, the superimposed load, I saw some values that have been imputed.
Okay.
Are they arbitrary? Are they something you pick from the table? Are they, how do you fix it?
Values of loads, right?
Superimposed loads. For example,
Okay.
maybe the earth pressure load, maybe the field on top of the deck. So I saw some values you are increasing.
Load combination. We are discussing about load combination. Yeah. So what it is doing is, we have already some kind of load cases which we have defined. So there is a temperature, there is a dead load, right? There is SIDL load, which we have defined. Now for a design, we need a combination of all, which would be included as per the code, which load to be added with all the partial safety factors. right?
Mm.
We have some fixed load cases. Now we are going to make a combination for design,
Okay.
right?
Based on the assumption of the designer.
Based on the code criteria. So code gives you certain criteria which load cases has to be added.
Okay.
Okay. So yes, so over here, again, I'm going to repeat the load combination part. So come to result, come to load combination. So over here, go to concrete design tab. Okay. Go to concrete design tab. So under concrete design tab, you use this auto generation function. So auto generation function would allow you to choose the code. So here we are referring to BS standards, everything. So once you select this, what program will do is it will create.
Gentlemen, in 5 minutes time, we'll be going for 30 minutes break. So exactly 12:30, we'll go for break and resume exactly 1 o'clock. Thank you.
So once we complete this, it will automatically create all the load combinations. So as you can see, there is a strength, there is a serviceability load combinations, right? And also the factors which are updated. So let's say if you consider one given combination, the factor is 1.35, 1.2, right? As per the code, it is being taken up. Is everyone able to see onto the left or right? There is the factor which is being applied for the design combination which we see. Are you able to get everyone? So now we are going to use the combination for the design. So define this combination, everyone.
So this is a fact.
Yeah, factor. We have a factor.
Yeah, this is a fact.
Yes. I think we are referring to that.
What are you factoring now? Because the factor
Load.
is
And
dimensional and has no
load.
units.
Load amplification. If I have 10, if I apply 1.2, it will be applied as 1.2.
If you apply,
If I apply 1 kilonewton as your load, if I apply a factor of 1.2, so it will be 1.2 times the load, 1.
if you apply 30,
Yeah.
let's say if it's carried to the trailer.
So you are going to increase by 20%.
By 20.
Yeah. That is a load factor.
Oh, okay.
So that is a design criteria. What limits that consideration? Yeah, that's correct. Yeah.
Okay.
Yes. Okay. Is everyone good at this point? Please let me know if you have any questions. Load combinations, how to generate the load combination. Yeah, is everyone following? Please let me know. So we'll come to the next part, come to results, come to analysis, go to perform analysis option. Is everyone able to run the model? Is everyone able to get this message? Once you run the model, your analysis would be successfully completed. It will show that your analysis would be successfully completed. Okay. Now, once this is given, go to results. So under results, you can check the results of what is your reaction, what is your bending moment, what is your shear force that you are getting. So all these particular details would be obtained into the result tab. How to check that? We'll see one by one now. So here we are going to see as reaction. So we'll come to reaction value. So if I have to check for dead load, what is my maximum dead load reaction? So I can just go to reaction. If you are referring to PDF, we are on page number 25. Okay. So you can refer to page number 25 and the step to see the reaction values. So how to see the reaction? So you can go to this result tabs. go to reactions, process option, select dead load, and then click on apply. If I have to see the value, we can turn on the value and the legend and then click on apply again. So here you can see that your maximum reaction would be visible along with the whatever the reaction at every support that you have. So just follow from page number 25. Okay. And if you have any questions till now, please ask. So same way, we can see the deformation also. So how to check the deformation? So you can go to this displacement contour. You can turn on the value and the legend, and you can see what is the maximum deformation that you are getting, right? Just a minute, as I know, like we are exceeding the time, but just give me a minute. I just wanted to finish with this. So here you can see that here you can check the deformation. So here you can go to this tab, check the deformation value. Now you can also see the deformation in millimeters. So if you want in millimeters, so you can check the deformation in millimeters also. So as you can see in the contour, it is showing the maximum deformation value to be 5.06 mm, right? In the center of the main span. Are you able to find everyone? You can check into your system. The maximum deformation value that you are getting is 5.063 mm, right? So you can check the results same way like the force and the moment, which we would discuss later once we are coming back from the break. Okay. So we would be waiting for here for an half an hour. Then we will join at 1 o'clock. Thank you. Thank you, everyone. And for yeah, so we'll wait for this is a main lunch time. Lunch break. This lunch break. This is lunch break. Okay, we are waiting for lunch. Okay, lunch break we will be having for half an hour. And we'll resume from 1 o'clock. Okay, thank you.
How did the round of applause this
Thank you very much. Sorry for the delays at the start because we were having a certain challenges to set up. But rest assured, we will be able to complete the agenda as set. Okay, thank you. Thank you for appreciation. I am glad. Okay, we will wait here now.
Well, thank you, everybody. Thank you.
Yeah.
Lecturer, who are in host now, our convener, Engineer Lawa.
Thank you.
Thank you, Colin. Thank you.
You can say it in mic. Yeah.
What place we would like to know the pronunciation of the name?
Yeah. Akshay. Akshay. Akshay.
Akshay.
Yeah, that's correct. Yeah.
Because you can't, my student in life, you can't know people's name by the spelling.
Yeah, I understand.
For
Yes.
example, my son is Tayo, and school somewhere outside Nigeria.
Okay.
You call him Tayo. Everybody is happy.
Yes, calling him Tayo.
I said, why did you allow them to call you Tayo? Say, oh, they allow you. But I said, no, you made for your name. So when I have the privilege to be abroad, my name is Kunle. It seems simple, but it's not.
Right.
It's there's an which is not UN.
UN, gotcha. Okay.
So, let me try and pronounce it now. Akshay.
Yes. Akshay. Thank you.
So you're welcome. Thank you.
Thank you very much. Yes. We are going to close the link. Not now, right? Is it allowed?
Yeah.
Are we going to close the link? No, right?
No.
We can keep voting. Okay.
Hello, please, can we pause the recording for now that we're on break?
Yeah, we resume back in 5 minutes time. But the extension as a result of necessity. People go for prayers and all this. Thank you.
So we would be starting. So everyone, for those who had some queries regarding, the installation still, I have replied to them. Kindly check. Otherwise, we'll proceed further to, the result and the design part. So everyone, just be there, everyone. So we would be moving towards the result interpretation part. I hope my screen is visible. If not, I'll share it again. So yes.
It's not visible.
Okay, I'm sharing it. I think I stopped the sharing. Yeah, now you can see my screen. Yeah, all right. Thank you. So let's move ahead now. So I request everyone to join who had been for the break. Yeah. So we are here up to results part. I hope everyone has done until this particular part, analyzing the model. So I'll just go one step back, what we did. Okay. So what we have done is we have come to analysis part. And to analysis, we have come to perform analysis option. So once we have given the perform analysis, we can see the results have now been showed up. Like the model would be now analyzed. Now what we need to do is we need to check the results. So how we would be checking the results is checking through reaction, then deformation, then checking the forces. Okay. And one more two things I wanted to showcase to you regarding, the wizard, which I think I have got some queries over WhatsApp. Yes. So let's say if you are in the middle of the wizard, so let's say if you are doing this wizard thing, onto the left, top bottom left, you will find the save as option. This option is typically useful when you have that set of data to be inputted. Let's say if you forget something, and if you're going to, by mistakenly something happens, and if you're going to close this, you can save the data over here using the save as option. Onto the left, there is a save as option, which I'll showcase to you. I think it's not visible over here because of the resolution part. So in that, you will see that there is a complete save as option where you can simply save the wizard file. Okay. So how to save that? I'll explain that. So let's say in the middle of that, you can use this function to save the wizard information. What is this save option? It is going to save your data. So basically, it is going to save your time when you are going to use the similar data next time. Okay. So you can save this wizard as a wizard file. Okay. So that is much more easy when you next time when you open, you can open the same wizard file instead of just inputting all the data from the start. Clear? And also for Civil NX, for those who are doing undo and redo button, you can see it over here where I'm pointing. These are nothing but the undo or the redo. Okay. So these options you can see it for to go one step back or one step forward. That's correct, everyone? Now we will go to the next step. So everyone, if you're following the PDF, make sure you are on page number 26, where we are seeing the results. How to check the results for deformation, how to check the results for forces, right? So those results we can simply check it. So here you can go to the results part. As I say, go to the results, and in results you can go to reaction. So in the reaction tab, you can go to forces moment. Here you can select the dead load values. You can turn it on, and here you can see what is the maximum reaction that you are getting. Okay. So the red one, which you are seeing over here, is the maximum reaction. Okay. All right. For those who are yet to complete the model, what I will do is I will send the model to you. Okay. Those you can just directly open the model. For those who are missing the step or somewhere they have lost in between, I'm going to share the model with them so that it would be much more easy for them to check. Okay. So I'm going to send you all the detailed file. Okay. So everyone just have a look. I'm sending out the detailed box culvert wizard RAR file, where you can also see the model which I have been using is the same model. You can open it. If you have not come up at this particular point, you can directly open this particular model. Okay. For the analysis and the design part. Everyone. So let's go ahead. You can see the reactions. So you can go into reactions, forces, select the load case or the combination that you want. So you can select the dead load. You can click on apply. So here you can see what is the maximum reaction that you are getting. So it is 29.1 as your maximum reaction. And like if you have to get these results in tabular form, how we are going to do that? I will also explain that part. But before going that, we'll check what is the deformation. Okay. So how to check the deformation? We will go to deformation over here, go to displacement contour. Okay. So in displacement contour, select the load case and click on deform and values option so that you can get what is the maximum deformation that you are getting. See, again, I am explaining how to check the deformation. You can go to deformation over here, check the displacement contour, right? Then select the component. Component as in which part you have to check the displacement. Eitherwise, it could be in X deformation, whether it could be in Y, or whether it could be in Z direction. Clear? In the similar way, you can check the forces. Deformation is clear to everyone how to check the deformation, right? Now we will come to the forces. How to extract the plate forces and also how to extract the beam forces, right? So we'll come to the forces option. You can see, you can see the steps which I'm doing. You can go to analysis result, and over here, come to forces, come to beam diagrams. Okay. Come to beam diagram. You can open the same model which I have sent. Better for those who have not completed or who are able to not logged in, just use this beam diagram option. Same model, and then you can simply run the model, and then we can start it from here. So use beam diagram option, and then use the dead load case. So you can see due to dead load, what is the maximum bending moment, right? So you can see that what is the maximum bending moment diagram that you are getting. So you could remember, right? For those who have just come out of it, you can just see how we are plotting the bending moment diagrams, right? The similar, you can directly get it. So those who have come out of universities or who have joined in today's workshop, they might recall like how you had been, extracting as a civil engineer, the bending moment or the shear force or the axial force in this particular part. It will be a, kind of revision for you, like, so you can just see how we can extract for the typical case, what is the dead load, what is the shrinkage load, right? So you can just change the combinations, and you can just see what is the typical results that you are getting out of this uh, result diagram. So again, you can change the load combination to any of the load cases that we have. So you can just simply select and click on apply. Yeah. Is everyone with me? Please respond if you are there. Is everyone connected?
Yes.
Okay. Okay, perfect. If you're not following, please let me know. We can have a revision of repeating the steps. That is fine. So if you have to select MY, so here if you see the MY is the bending moment along Y, right? So this component we have to see. So if you have to, as a designer, if you have to see what is the maximum, what is your direction of a main perpendicular axis is in this way. But about perpendicular axis, you will be getting the moment. So it has to be about Y. Why I have selected typically MY is because you have to check the bending about Y. This bending we have to check. Are you able to follow? And now if I select MZ, what would be the MZ? It would be the bending about Z direction. Okay. Now what is Fx? Fx is nothing but your axial force. Okay. So this is your axial force. Mx is nothing but your torsion. But since for the dead load, we won't be getting any torsion. Fy, Fy is your shear component in Y and Z. Okay. So if you have to check the shear force, we can refer to F. If I have to check the bending moment, it has to be My or Mz. Okay. So now if I ask you in a major bending direction, if you have to check what would be the component, it would be My, right? It would be My. Why? Because it is rotating about Y. Just imagine the axis. You have this X, you have Y, and you have Z. So if I have to see that your bending is being caused about Y axis, it should be about Y axis. So is the reason why we are checking for My. Clear? How to get the direction and the sign convention of this? It is with respect to the axis. So I'm going to explain this part. So if you have X, Y, Z, okay. So this is your X, this is your Y, and vertical would be Z. Okay. Imagine in this way. So this is X, this is Y, and this is Z. Now you have applied load in this particular direction. Now your bending would be caused about y-axis, right? So it will be about y-axis. The bending would be caused about y-axis. So is the reason why we are seeing the component as my as a major bending component. Your bending of the beam would be something like this. Clear everyone? Why we have to see my? Correct? See, this is your beam, right? Now, if I apply the load, it will bend. This will bend, right? But it will be about this axis, not this axis, perpendicular, right? So we have to see the my. Now, if I come back over here, you can see that these are the other load cases and the combinations that we are seeing. Okay. Again, now next step is the case. So if I have to see the results in a result tabular form, you can go to result tables, you can go to reaction, and here you can select which case or the combination you want as a tabular form. So you can see all the reactions over here. And now here you can easily compare what is the summation of the dead load that you are getting, right? Again, same for result table. If you have to check for forces, you can go to result table, beam, and the force stress option, where you can simply select the load cases or the combination and click on OK, right? So these are the tabular inputs that you would be getting. If you have to obtain the results in a tabular form, then you can simply select the result table and you can click on apply. Correct? So you can refer to this PDF also. I think PDF doesn't have this result step, but however, you can just check the detailed steps that for the result table. Okay, how we can check the result in a given result table. Now, after this, we'll move towards the design. Once you are done with this, we will move towards the design part. Okay. So everyone just please note, have you able to check if you are able to get the result in a tabular form or not? Yeah, can you confirm if you are with me online, those who have joined? If you are able to see the results, please check what are all the results that you are getting through the tabular form. Now we'll come to the design steps. So everyone, those who are following from the PDF, come to page number 28. So we'll start with the design. Come to page number 28. Okay, come to page number 28. And also please open the PDF page number 28. Please open the page number 28. So we'll start with the design steps now. So we'll come to the design part. Here we are going to select with the RC design. Okay. So make sure we are selecting RC design. And also here we are going to select the code. So let's select BS code. Okay. So we'll be selecting the BS code. And over here, we would be selecting what is the modification of the material. So if you have to modify the materials, so you can add it if required. Okay, design code. So come to page number 28, everyone. Come to page number 28. So come to modify RC material. Here you can just input the code. So I'm selecting here as BS code. So here, once you select the BS code, you can directly select from the drop-down list what is the grade of material that you have. Okay, so referring to page number 28. So just complete this particular step, everyone. So complete this step. So once you complete this, we'll come to the next step, which is on page number 29. So for getting with the beam design, so we'll close this. Click on modify. Once you select the rebar selection as code. So why this step? Because we are telling the program, this is the code that I'm going to refer for my design. Okay. And let's say if there is certain change in design, we can modify at this particular time only. Okay. So complete up to this point. So we'll move forward. So here we'll go to RC design, come to beam design option over here. So once you click on beam design, so now we are moving towards design. Everyone, please check that. Once you enter the modification of the material, then come to RC code design. There is an option called RC code design. Just everyone have a look. So everyone just check that you are able to get this design option. go to RC code design, use beam design over here. You can just simply select beam design, and you can see that all the members have been designed now. Okay. So as you can see, each of the beam member have been designed, and how to check the results I'll explain now. You can just refer to over here. You can select a beam. You can check the result in a graphical form where you would be getting all the results in a detailed way. So here you can see that you have the design code information. There is a section diagram. There is a bending moment capacity check, right? Which software would check. So everyone just have a look, everyone, please, if you are getting this report or not. So you can see the checks. So as you can see into the section diagram, so what is it is showing is, it is going to show what is the top reinforcement, what is the bottom reinforcement that you are getting, and what is the stirrup data that you are getting, right? So that is the information that is available once you design the section. Then we also have bending moment capacity check for negative moment, positive moment, and also for the shear capacity, right? Are you able to get, everyone? Can you just confirm if you are able to get this report, or I need to repeat? So just check if you're getting this report or not. In this, you'll be having all the checks. Also, second thing is we can even check the detailed report check as well. So here, once you click onto this particular part, come to member part, here you can just view it as a detail. So once you click on detail, you can see all the design report would be generated. So this design report would constitute, or it will have all the information pertaining to the design code that you have used, whatever the material that you have used, and also the total rebar, the total rebar area which it is giving for top and bottom reinforcement. Okay. It will also perform different stress check for negative capacity and positive bending capacity. Okay. So it is giving you, if the checks are not satisfied, it will show as fail. Okay. If it is getting satisfied, you can see it is giving it as okay. right? So even it will get all the checks done as per the code. Can you just produce a report? If anyone is not able to get the report, please let me know. If you are able to get the report, please let me know as well that you have generated a report successfully.
How can you take it to Word?
Yeah, I'll explain that part. So once you click onto it and see the graphical result over here, see what is the brief check that it has been satisfied or not. After that, select member, select on member, and after that, you just use this one. You select the member which you wanted to see. If you want to see which member is there, you can use this connect to model option also. So here connect to model. So you will be able to see if I am selecting which element. So it will accordingly highlight. Okay. So here you can see that it is highlighting 1, 2, right? So if I have to see for this part, you can use this detail report. Come to member and use detail report option. In detail, you will be getting the detailed output of in a Word file with all the information of checks of the stress which are being satisfied, and also like the stress checks as well. So click on member. First, you have to select the member over here. You can see my cursor. Select the member. Again, if you are referring the PDF also, in PDF also there will be information about this on page number. Yes, in detail. Nothing in PDF, it is not included. So you can go to this part, click on detail. Okay. So in detail, you will be able to get the detailed report of it. Are you able to follow? Just check. For the detailed output of the report, you will have to come to this member option, select the section that you want to output and click on detail option. Then you will be able to get the detailed output of the word form. Everyone, please get this report. Please make sure that you are getting the report.
Yes, we have done that. Thank you.
Okay, perfect, perfect. So you can see how easy it is to get all the detailed report as per the code compliance, like as per the code check. It will give all the detail, what is the maximum minimum rebar ratio to be used, what is the maximum reinforcement ratio, right? What are all the design parameters, what is the bending moment capacity check, right? So again, these are something, the options or the stress checks which would be shown into the design report. All right. So for those who have completed, please check if you have any questions in between until this particular design part, as we are quickly seeing for the beam design. Now, if I have to design for column, how to do that? So I'm going to explain how to check for the column as well. So over here, you can go to RC code design, and over here again in the same way, you can check with the column design. So there is a column design option available over there, right? So it is a column design. So here you can just check over here and use the graphic function where you can obtain what is the PM interaction curve for your column. Okay. So in detail, you can also carry out the capacity check for the axial moment and bending moment capacity check. Okay. What is the applied load? What are all the design conditions that we have? And also the shear stress capacity check. Okay. So all these options you would be getting in a graphic output. In the same way, if you have to check with the detailed report output, go to member first. Onto to the top, you will find that it is sorted by member. So use this member option, select this and use this detail option. So once you select the detail option, you will be able to see what is the total, the rebar area, right? So what you have got based on the total end support and mid support, and also the axial and the bending moment capacity check, and what is the PM interaction curve, right? So this detailed report output can be extracted based on the design that you have performed. Okay. So again, same for column and beam, you can obtain.
Excuse me.
Yes, yes, please.
Please, in case of failure, for example, how can one
Yes.
do one go back and edit the member sizing, or maybe change
Yes.
the rate of concrete and then rerun the analysis as well? The result will be automatically updated. I just want to have like a clue of how it's been done, or if there is a shortcut of how one can actually.
Okay, no problem. That is a very good question asked by engineer. So here you can see if you have two options. If the member fails, what you would be doing is either you can increase the capacity of the section. How you will increase? Either you will go on increasing the grade of material or you will change the section. Okay, if you have to change the grade of material, you don't have to go back directly. You can just use this modify concrete design material option. Here only you can increase from C35 to C40. If you have chosen C25, you can choose the C30. You don't have to go back from the scratch of defining the material. Once you update the material, automatically the section would be checked for C35 grade of material. Once you update C25, accordingly the design checks would be done for the C25. But if you have to change the section information, so what you have to do, you have to come to this tab over here. Now let's say I want to add up some other dimension. So right now it is 325 by 1000 mm. So what I can do, I can increase the depth or the height by, let's say, some 10 percentage or 15 percentage. So based on that, I can edit that, run the analysis and perform the design. These are the two steps which involve when particular members fails. Okay. Apart from that, you can even check that for if let's say if the member fails by any chance, then it will be shown over here as not good. So here it is showing okay, right? But if it is not good, it will be shown as not good, NG, in a red color. Okay, is this clear? Is this clear? Yeah,
It's clear. It's okay.
thank you. Thank you. Yeah. Yeah, please. Okay. Okay.
You're talking about moving from grade 35 to 40. You're talking like everybody's working this situation where you have batching plants and whatever. Well, like percentage. Let me just leave more 70%. Not like lower and behind. Like far from the total.
or about 70% of people that are pouring concrete, we don't have batching plants. So changing from 35 to 40, it's cumbersome. Even for them to do grade 25.
Okay, I agree. Yes.
Is almost impossible.
Right.
Once it's on your back, they are mixing grade 18.
Yes.
So how do you manage?
No, it is something related to the operational aspects. Like it is based on non-ability, right? In that case,
Based on what?
it is based on like certain challenges, right? And not everywhere it is the same thing, right? Over here, you might have that situation. But in other countries, we have the easy ability of changing the grade because it is easily available at different batching plants. But let's say here, if that is the situation, then why we can't adopt the higher section sizes, higher thickness? So that option we have. It is just that with the same amount of C25 or C30, we're going to require additional concrete. Not changing the grade, but just changing the section size. Yes, that's right. Am I correct?
No, you're correct.
Yes. 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 That's right.
So we're now debating the total 35.
Yes. No, that is just the example. That is just the example. Yeah. In any case, if it is changed, that is just the example.
I need to do this.
Yeah.
Sorry. 2 minutes.
Okay.
With the slab on top of it being V-shape, sketches. I mean, it's slab. It's supposed to be a tall one, but there's an existing tray.
Okay.
V-shape tray.
Okay.
So we're supposed to put a slab on it.
Okay.
And fill out next to it.
Okay.
Coincidentally, it wasn't wide enough. The span is about 1.5.
Okay.
Based on the post, span is 1.5. Because the V shape.
Okay.
So it goes from there into 1.5. So we designed it for a trailer to go on.
Okay.
But far that is not wide enough.
Okay.
So in order to make it, because of economics,
right?
Because I already cast 4.5, I wanted to cast about 2 meters more.
Okay. Extra width of the. Okay.
And we also thought of how to carry.
Okay.
So we now have 0.9
Okay.
for 1 meter, 1 meter.
Okay.
Wide, so that we can carry.
Right.
This. So on carrying it, when the trailer came, but it was designed that there would be a smooth, right? There's a major room.
Okay.
So when it wants to turn, it comes and move.
Okay.
Onto it.
Right.
While it was going, the small breakfast.
Okay.
List. Or cracks.
Okay.
Or I mean, cracks. Yes.
Okay.
But this other one, So what I'm saying is, I would love to give us as a case study.
Okay.
Let us design it. Let us instead of the 4.5, let us be give it 6 meters.
Okay.
And sooner or fail, say the 4.5 is enough. But now that we now casted little parts.
Okay.
But we are believing that maybe because of rigidity.
Yes.
For some reasons, why do those ones? Is even one of
Maybe like it could have been a case that thickness would not be sufficient.
You what?
Thickness of the slab would not.
Thicker.
Okay.
We made it 270.
Okay.
Millimeters. One is about 310.
Okay.
It was about 310.
Okay.
So, and but that's the scenario.
Okay.
Love it to put as a case study whereby maybe we can look at it and make it like
Yeah, sure, we can do it. We can. Yes, certainly.
so can I just get it or I can just send it to you?
Okay, we can do it later. Yes.
Yeah, I tried. I think the system is working.
All right. So, is everyone able to complete up to this part?
Okay. Yeah. Okay. What I said is that I would have loved to give a, a real life case study whereby we did a slab on top of an existing drain. The drain is 1.5 meters span, and the slab is
Okay.
span down, but the length of the span is supposed to be about 6 meters. But initially, we casted 4.5.
Okay.
So when the trailer came, we couldn't accommodate it. So we needed to add about 1.8 meters to it. And in order to carry it, because the slab is about 300 mm thick, so we have to cast it in zero point 0.9 meters per 9 meters so that we can carry it and place. So, but when everything has cured and the trailer came, the 4.5 had no issue, but the one that is casted as a precast,
Okay.
yeah,
Okay.
I mean, cracked. So the trailer quickly went in. Though what the trailer was supposed to do was to come in gradually into the compound, or maybe was pressing the brake, was doing all sorts of things.
Okay.
So what I'm saying is that I could keep a sketch of it. We could do it like practice,
Yes.
whereby we can now examine, and come up with why and how
Yes.
to.
Certainly, we can do that. Yes. Yes.
So because I have to leave next week, I have a meeting today.
Okay.
So if you don't mind, I can please sketch.
No, we can discuss when you rejoin tomorrow, so we can continue from them. Since we are having the agenda, we can complete that, and after that we can come to the problem statement. Yeah, because
And
you will be requiring here. So based on that, we can continue. Tomorrow we can continue, no problem.
okay.
If you are living now. Okay, so now let's move ahead. So is everyone able to get the results? Please check. At least the design report you are able to get. So just check everyone if you are able to get the results. I mean, in the design report.
Yes.
Okay.
But the figures are quite different from yours.
Sorry.
The figures here on the screen are quite different from yours.
Okay. Let me showcase that as well. So here, if you see, you can go to RC design. What is this on the screen? How to remove this? So here we will start with the next example. So if I have everyone finished up with this, then we can start with new example. Okay. So if you have to get the results, so I will explain last time how we have done. We will just have a recap. So what we have done is we have defined the material properties. We have generated a geometry using the wizards, and then we have inputted the wizard property in terms of longitudinal, transverse, and loading definition. And then we have seen some of the loads to be assigned as elemental loads onto my beam, and further the analysis, how we can get the analysis for different load cases and combinations onto our bridge structures, right? And after that, we would be giving with the supports, right? How we are generating the point spring supports and all that. And after that, we are going with the detailed design output. So once we are going with the detailed design output, you can go to design, you can go to RC design code, and you can just hit on beam design. So once you click on beam design, you will be able to check all the results in both graphical and in a detailed format. So you can just click on graphic and you can just see that it is in a detailed format, right? Apart from that, you can also go into the detail tab where you can get all the detail check. Correct? Everyone able to follow? So you need to practice once you go home. Okay, you need to practice this example for those who are not able to do. You just have to follow the steps. Okay. Now, shall we move towards the next example? If you have any questions, please let me know. Otherwise, we'll go with the next example. Okay. Please respond if you have done. Yeah. Okay.
But what is obtainable in the field? I know you're talking about game design.
Yes.
Can you give your I'm not on English. So because I want others to know somebody's talking. Okay, people outside are more in number than us there.
You can give phone to him like.
Okay,
Yeah.
Okay, I know what is obtainable in the industry
Yes.
is as regards beam design. I think the span and load bearing supposed to have some things to play in it. Or how do you generate all those your data? Okay, Engineer Amin just asked a question now, but the reply is that I think it came a bit late. We started with the with the foundation, that's the soil, the bearing capacity. So all these things have been mentioned. Also, Engineer Amin is a mechanical engineer, so I mean he's taking advantage and also joining us. So, but maybe if there are other questions, I don't know whether I've answered. So there's a relationship which he started with, and probably because you came a bit late.
if you are talking of a game that is not more than a game, I am talking of
Okay,
I know there's nothing.
sure, definitely.
What is responsible for the
Difference in what?
in the design? Sometimes you need the height of the beam.
No, the thing is that the basis for a 3 meter beam is different from the basis for a beam. It's just like a rope. And we can take you back to elasticity in the secondary school. If you have an elastic that is 1 meter long, and you have the same elastic that is 2 meter long, their behavior and characteristics will not be the same. So there's some basic information you should have to appreciate and to be able to know what we're saying. But since you are a mechanical engineer, so you also deal with materials. So when you go back to strength of materials, a beam of 3 meters will not be as rich, will contain less material, restraining material than one of 6 meters. So all these are the basics of strength of materials which you are supposed to know. And this class is actually talking about practice and use of software to do all those things that we're doing manually. So we won't necessarily be discussing that, but I yield to the lecturer. Maybe he has a better answer to what I'm saying.
Yes.
So,
So basically, what they are asking is about the load bearing, right? Am I correct?
also, we should look at it.
What I'm saying, in essence, that if
Where we are, it's a three-story building, for example. When you get to where it is the normal construction, not the steel reinforced construction, you see that you have to have as a column and the beams down is always more than when you are making a structure that is not as high as this, or depending on maybe it is a commercial or it is residential. So the design differs most of the time, and that is what I'm saying. What are the consideration?
Okay. So see, typically when you design any structure as a civil structure, right, you need to get the appropriate load demand. First thing, you calculate the loads, you note what is the total loads, and for that, you need to work out a section which is having the capacity more than what is the load demand. Correct?
yes,
So if the section is not adequate, how we are going to design the section for the underrated or underestimated load demand? We can't do, right? As an engineer, we can't do that thing. So we need to take care of the load account, total load demand into consideration. With regard to not only load demand, it is based on the combination that the code suggests. So we'll take that demand, we'll design for that demand. Whatever the capacity that it is going to satisfy, that will be our final section. Am I getting you? Yeah. So we need to calculate. As an engineer, we need to know what is the total demand that we are going to design for. We need to anticipate. Maybe for building structure, the loads would be different. Maybe for bridges, it is different. The application is different.
So the first thing is you size the elements. I think that's the very. I remember that's the very first class I had in civil. Okay, what are all the loads? What is the size of the elements that you want to use? Because you have chosen your material, whether it's steel, whether it's concrete. So what you now size the beam? Do you get? So if I remember the way you started the question, I think the lecturer has answered. So sizing the elements is a very fundamental and primary thing to do.
Yes. Thank you. I hope now this is clear to everyone. Okay. So let's move towards the next example. Okay. So we'll take the next example now. For those who are not completed or yet to complete, you can refer the PDF. If you have any questions, we can discuss tomorrow. Okay, morning. So as of now, let's start with new example. So click on File, New Project. Go to File. Click on New Project. So we'll open New Project. Is everyone with me? Please let me know. We are going to continue, okay, right?
Yeah, I'm with you.
So now we would be starting with 3D example. The same for the box culvert, what we did. It was in 2D. Now another example, we'll be focusing on 3D. So in 3D, we will see what is the difference, what we did in 2D and 3D. So when we talk about 2D, what are all the cases? And in 3D, what will be the typical cases that we have to consider? Clear? So let's start. So I'm going to share the tutorial also for that before we start the example. I hope no one, everyone is with me. I mean, no one is lagging behind. So I'm going to share the tutorial in a group again.
Scheduled for them back to so back next one more as you wish to this is congrats. Sorry, permissions.
Oh,
See you tomorrow.
yeah, see. Bye-bye. So I shared a tutorial in a group. So everyone please open the tutorial. So we'll be starting with next example. Okay. Same example, but using the 3D example. One is 2D and second is 3D. Okay. So everyone just open the example. Now I want this to be done by you. At least 1 or 2 step has to be done from your side. Okay. So I'll just check if you are having any issues in defining the material and the section and applying the wizard. So everyone just open the PDF. Same example. It is having the similar example. No change in data. It is just that you need to define it from your end and,
Thank you, sir. À 17 ans.
Yeah. Hello. Yeah. Okay. So everyone just open the PDF. So we are starting with another example. Okay. So again, you can see the type of bridge would be the same 3D culvert. There is a clear span of the box, which is 5 meter. Thickness of the side wall is 0.35. Clear height of the box is 3.5 meter. Then what is the thickness of the deck and the base slab is 0.325. Then idealized span is 5.35. So everyone just open and start modeling this example. So you can just see into the PDF, given PDF, and I will explain the new part, at least the one which we have covered. I request everyone to do it from your end, defining the material, okay, the material property and the geometry using the wizard. Okay, so just do it. So just start with defining the material first. Come to page number 5. Come to page number 5. We start from page number 5. So just start from page number 5, defining the material. So once you are done, please let me know with the material. Then we'll move towards the next step, explaining the next part.
Yes, we can move on.
All right. So now next step is going with the using the wizard. So now I'll explain what is there in 3D.
We are not
So
there yet, please.
yeah. Yeah. Which one? Yeah. So you will not be able to edit. You can directly define. Once you define the properties, so yeah, I'll explain how to define that. Go to properties. Okay. Go to properties. Go to material properties. Click on add. And over here you can select the concrete. And here you can select the grade of concrete. So since we are referring the BS code, so you can directly select the grade of concrete as C30. Okay. And then you can click on OK over here. Okay. So define C30 as a grade of material. So come to this point, come to material properties, click on add. I'm explaining how to define the material properties. Go to concrete. So here, select the code as BS, select from the database as C30 grade of concrete. So click on OK. So this is very first step. Okay. Now, next step is to define the structure tab. So go to structure tab. So everyone just go to structure tab. We will be inputting the data over here. So go to RC frame again. Now here we would be selecting 3D box culvert. Instead of 2D, we will be selecting a 3D box culvert. So now refer to the PDF that we have. So selecting the grade and then again defining the property of the span. Again, what would be the span? The same span we would be using as 5.35. Okay. So we are not going to consider the wing wall. So we'll remove this as wing wall. We are not going to consider. Size of the plate element as 1. Skew angle, we can keep it as 0. Then T1. So T1 would be again 0.325. Same data we would be using. Okay. T3 is 0.35. So just enter from the PDF. Okay. So again, T4 is 0.35. A1 is 0.3. A3 is 0. B1 is 0.3. B5 is 0. H1 is 4.175. H2 is 0.065. So we are going to enter the H2 and PS same 0.065. Here also 0.065. Okay. So everyone just enter the span data. It is in the longitudinal tab. Then next step is everyone finished up to this part? Please confirm. You're still doing? Okay.
We are on it, please. Sorry.
Sorry?
We are on it.
Okay, okay, no problem. Now let's come to the transfers tab. So we'll come to transfers tab, definition of the transfers information. So in this, we'll go to this transfers option, right? So here we can give the size of the plate element as 1, then B3 as 0.45, B4 as 0, B5 as 8.75, B6 as 0, B7 would be 0.45. Now the modulus would be again the same. It is 7630. Then we will click on OK. All right. Now after that transfers, we come to load. Again, the load would be the same, which we would be defining. So you can just come to page number 8. So define self weight, then pavement. So define weight density as 22. So here also weight density as 20. Soil we have to consider. So surcharge, we are not considering it as 0. Even there is no underground water, so underground water density would be 0. Then barrier, 11.25. Right, so we are not considering the sidewalk, so we are just removing the sidewalk, and only the temperature gradient we are considering as 17.5. System temperature we are not considering, and there's the thermal coefficient value. Now, what is the thermal coefficient value? What is its significance is we have to consider the, what we say is the thermal effect. So for designing our structure, there will be thermal actions that would come up. To account for that strains, we are going to consider the thermal gradient. Okay. So once you enter this information, click on OK. So do it up to this part. So everyone, just complete up to page number 8. So complete up to generating the model. So wizard, you can see that your model would be generated over here for your 3D box culvert. So now here you can see the actual thickness we have modeled it in a 3D. So we have actually modeled it in a 3D, considering the width and the span that we have defined. Clear everyone? So complete up to this part, then we will move forward. Yeah. Here, save the model also as 3D box culvert. Save the model as 3D box culvert. So complete up to this part. Once we finish, everyone generates the model, then we will go forward. So just see the steps which are there. So it is the same data that we are inputting. Okay. So after that, please confirm once you have finished. So yes, we have 10 minutes left for today's session to close or call off. So I request everyone to generate a model, and further we are just remained with the analysis and design, which we can start up for tomorrow. Meanwhile, what we can do is we can have your queries that and also the feedback from your end for today's session. Okay. So yes, I think we are close to ending the today's session. But however, you can always let us know if you have find this session to be useful. You can just write to us if you have any queries further. Okay. So please let confirm once you have generated this. Then we will go towards defining the other aspects of model generation. So how to create the moving load. So it, we are remained with the moving load. How to apply the moving load in 3D. Okay, so we have to actually load the vehicle onto the bridge. Which vehicle we would be using, that also we will see. Okay.
Hello, sir. Can we answer the question?
Yeah, please let go on.
Yes. In the setting where we are changing the orders, you made a mention of groundwater, and we
Yes.
know the culvert is always having a water.
That's right.
So
That's right. Yes.
is there does the groundwater does not have effect on the culvert
Yes,
base?
yes, absolutely, engineer. Wherever we have the culvert which is submerged in water, not the case. I mean, like it could be the case that it might have a railway pedestrian under pedestrian bridge where it is supported by soil from both the sides. But however, there is underground water level, we do have to mention what is the underground water level. So it will automatically take the groundwater level from the start. And based on that, the submerged weight density would be considered. Meaning is the weight that we have to account for soil is not the dry weight, rather it has to be saturated weight density of the soil.
Okay.
Clear? Yeah. That is very valid question that you have asked. All right. So once this is done, please let me know. Excuse me. You can switch off the AC. If she is feeling good, we can switch off the AC. Okay, so everyone, please check. If you have any questions, do let me know. So we will start the very next part from tomorrow morning, exactly at 9:30. So yes, so we thank you everyone for joining for today. Okay, so for those who are still yet to, have certain challenges, you can let me know. So meanwhile, I'll stay for those to resolve. Okay, but do practice this after the post training hours. So I would rather request everyone to have a go through, because ultimately, the more you practice, you will be able to get hands-on onto this Midas, and you will be able to see in the way that you are going to save the time, ample time, when you are doing with the conventional modeling, and further you are going to do with the software calculation. All right. So I thank everyone for joining for today. I hope the session was useful, and I hope to see you again tomorrow at 9:30. Thank you. Yeah, thank you. Yeah, no problem.
Yeah, thank you very much.
Yes, thank you.
Thank you very much, sir.
No problem, no problem.
Yes.
And also, we would be sharing the recorded link for today's session as well. Once it is being recorded, so we'll be able to share the recorded link as well. Okay. Thank you.